We can find the acceleration of a free-falling object if we know the velocity at two different times and the time interval between the measurement of those two velocities. In order to measure the velocity at 2 points for a falling object, time has to be measured very carefully. And to do this, we're going to use a photocell that is basically a little small circuit with a photoresistor that plugs into the headset jack of a cell phone or tablet. This is a schematic of the 4-contact headset port plug and the resistors and capacitors that make up the photocell. The photoresistor is shown as a variable resistor because it changes with the amount of light that reaches it. Here are the values for the resistors and the capacitance that are used in the circuit. The cell phone app Mobile Science Audio Time Plus sends out a signal through the headset port, through the resistors, and then looks at the return signal. If the resistance changes, then the amplitude of the return signal has also changed. And it's this change that's used for timing the photogates. Because the light doesn't drop off immediately, and also because of hysteresis effects, the best method is what's called a double flag method. The beginning of the dip of 2 successive dips is used for a timing instead of trying to find the length of one dip. Here's a typical setup with 2 photogates taped to a wall and the piece of plexiglass with 2 pieces of electrical tape on it to make the 2 double blockages. As the plexiglass is released, it falls past each of the photogates, producing 2 dips at each gate. There's a button in the app that will allow you to find where the intensity is dropped by 80%. Using the button a second time finds the next position where the intensity is dropped by 80% and also calculates the interval of time between the 2 drops. In this screenshot, we can see where the intensity is dropped in 2 different places as the 2 stripes passed one photogate. Also, at the very bottom, you can see that there's a time interval that's been calculated between the 2 dips of about 0.10 seconds. The distance between the 2 leading edges of the 2 strips of tape on the plexiglass can be measured, and with the time interval measured by the app, we can find the average velocity as it passes each of the 2 photogates. With a d value from leading edge to leading edge of 12 centimeters, we find, using the timing data from the app, that the velocity at the first photogate is 1.23 meters per second, and at the second gate, 2.98 meters per second. We can now go back to the app and find out the time interval from the first leading edge to the third leading edge, and we can average that time together with the time from the second leading edge to the fourth leading edge. That gives us the average time between the 2 measurements of speed. Using this time between the 2 speeds and the 2 previously measured speeds, we can find that the acceleration of gravity in this case was measured to be 9.45 meters per second squared.